Hello and everyone. Thanks for coming for my today presentation. My name is Hazem Saleh. I had been working in software industry for more than 15 years. Currently, I'm working in Viacom, New York as a software architect. Today, I will be talking about effective JavaScript unit testing. So there are three main parts of our presentation today. The first part, we will discuss traditional code coverage. How can we achieve traditional code coverage today in our JavaScript applications? And I will show you a real demo of code coverage. Then we will start discussing the current challenges of traditional code coverage that we have today. How can we overcome these traditional code coverage challenges? And we will prove today that traditional code coverage is not really an efficient way to measure the strength of our unit tests. We will be seeing mutation testing and Stryker as a good JavaScript mutation testing tool. We will see a demo of Stryker with our custom JavaScript project. Then the last part of this presentation, we will see integration of Stryker with Angular project. So what is traditional code coverage? All of us know is traditional code coverage. Traditional code coverage refers to the amount of lines of code that are running when unit tests runs. It has three main criteria: statement coverage, function coverage, and branch coverage. So statement coverage refers to the amount of statements that are executed every time we run our unit tests, and the same with function coverage. Branch coverage is different in a way that it shows us the amount of branching that are executed every time our test cases runs. In JavaScript, there are so many great tools which can allow us to do code coverage. One of the most popular tools is Istanbul. And if you are using KARMA as a test runner for your JavaScript unit tests, then I recommend you to use KARMA coverage. KARMA coverage is a tool that is based on Istanbul. It gives you this ability here. It gives you the standard code coverage criteria. It shows you statements, branches, functions, and also the lines of code. You can install it directly using this npm command. To configure it, you need to do three main steps here. The first step is to define the preprocessor. So the preprocessor here, in the preprocessor, you define the source file location. So you are telling KARMA coverage about the location of the JavaScript files that you would like to run a code coverage for. The second thing here you need to do is to configure the reporter. You need to configure the coverage reporter, and finally the coverage reporter configuration, which tells the plugin to generate the coverage report under which path and what is the format of the generation. So let me show you an example now. This example, again, is available in GitHub. So feel free to download, try, and ask me questions, and I will answer later on. So this is a simple JavaScript project that we are having now. So we are having JavaScript class. It's called a rent classifier class. So in this class, it has a constructor. It takes some object called audit manager to do some logging. And here it has some method called classify. It takes a price, rent price, and based on the price value, it determines if the price is low, average, expensive, or very expensive. We can run it here. You know, it is very simple page. So let's really write unit tests for this class. How many of us is familiar with Jasmine? This is excellent. So here we have a test case some test case called rent blight classifier test case. And here, before each, we instantiate the object that we would like to unit test. And here, we do usual unit test here. Here, we challenge the classify method with different values, with 1,000, 1,700, 2,900, and 5,000. And we assert the values. We assert that we take some value from low, some value from average, some value from expensive, some value from very expensive. And we did our unit tests. So let's run these unit tests to see if they are working fine or not. As we see, it is all good, right? So as a second step, usually in our projects, we integrate code coverage report to see how good are we right now. So in this project, I integrated KARMA coverage. So as you see here, I defined the preprocessor to be source JS to include all of the JavaScript files that we would like to run coverage for. We specify the reporter, and finally, we specify the coverage path. So let's now run the coverage report. Let's see how good are we right now. So we will navigate to the coverage directory. We will open index.html. As we see, coverage reports say we are 100% covered. Function coverage is 100%, statement coverage is 100%, and branch coverage is 100%. Unfortunately, many projects falls under this problem. So now the project developers can say, you know what, we are now covered. Our logic is really asserted very well, and yeah, we are almost bug free, right? The answer, unfortunately, no, we are not bug free. Let me show you a problem now. I will prove it now. What is the problem of this report that we currently see? The problem of this report is traditional code coverage is really measuring only the lines of code which are executing when unit test runs. But it has no idea about code faults. It is just executing the statements with no idea what is the logic that you are currently have. So it does not really guarantee that unit tests will fail if there is a change in a logic that was not asserted before. I will prove it now to you in this example. And this really means that it doesn't show how strong your unit tests are.
Hazem, your screen. Just behind you.
Yeah. So how can we solve this problem? Mutation testing is here to solve this challenge. Mutation testing is a concept which does not only exist in JavaScript. It really exists in Java. It really also exists in other languages such as Swift. You can do it in Swift as well. So what is mutation testing? The idea of mutation testing is to seed the application source code with something called mutations. Every mutation is about a change in your logic. So if you have something like some expression like a plus b, it will try to change it to a minus b. So after doing this change, mutation testing tool will try to run your unit tests again. If your unit tests really fail, this means that your unit tests are really strong enough to detect this code fault. And so if some new developer today come to your project, and by mistake changed some line, some logic, some code logic, so he or she will really find that the unit test fails and you are really covered. So a mutation is called living mutation if unit test is succeeding, which means that if unit test succeeds, this means that your unit tests are not strong enough to be able to detect this code fault. If unit tests fails, this means that your unit tests are really strong. You are really asserting every line of code. So in mutation testing, we can say the quality of the unit test can be measured by the percentage of the killed mutations. So what is Stryker and why should we use Stryker? Stryker is an open source project that does mutation testing for JavaScript. I prefer Stryker because it is powered by CLI. It is an active project. So if you have questions, you can post it in the project GitHub, and people, committers are really responding very actively. Very easy to configure, compatible with JavaScript, custom TypeScript. It is also compatible with the major three top frameworks that are currently used heavily in web world, Angular, React, and Vue.js. And it provides easy to read report. It has some mutations. So the mutators which are in the framework can be arithmetic operator, array declaration operator, block statement operator. So arithmetic operator is the case which I discussed with you. If you have something like a plus b, it will try to change it to a minus b. It has something like array declaration operator. So if you have an array that has a, b, c, it will try to just remove these items and make the array empty, and will try to challenge your unit tests. Another great operator is block statement operator. So if you have a function f1 which is calling another function f2, what it will try to do is just empty the block of function f2 and will ask your unit tests, did you really assert what f2 is doing? It has assignment expression operator, so if you have plus equal, it will be changed to minus equal, and vice versa. It has conditional expression operator, so if you have some condition, if a less than b, it will try to just remove a less than b and put true, or just remove it and put false. It will try to challenge every line of code that you are having. It has Boolean literal operator, so if you have var x equal true, it will try to change it to false, and vice versa. Equality checks. If you have something like a is less than b, it will try to change it to a less than or equal b. String literal. If you have like some string here with some value, Stryker was here, it will try to change it to empty value. If it has some empty value, it will try to put some strings there. I will show you demos which will explain this. And logical operators. If you have AND, it will change it to or will change it to AND. Update operators. If you have plus plus, it will be minus minus. Unary operators. If you have plus a, it will change it to minus a, and so on. So how can we install it? Just like any other NPM tool, you can install it using npm install Stryker CLI. And from the root of your project, you start to configure Stryker. You just type Stryker in it, and Stryker will ask you some questions. First of all, it will ask you, what is the test runner that you are using? Are you using Karma? If you use Karma, you select. If you use something like Mocha, you can use Mocha. If you use Jest, you can use Jest. Whatever test runner you are using, it is compatible with. And also the test framework. If you use Jasmine, if you use Jest, also the kind of code that you would like to mutate. Do you try to mutate JavaScript, or you are having really TypeScript that you would like to mutate? And finally, it configures the reporter, and it asks you for the package manager. It can work with npm and yarn. After you do this, this is the configuration file which is generated for you. It has these sections. In the beginning, it has the mutate. So the mutate here is like the preprocessor that we had for Karma coverage. So this is the JavaScript files that will have mutations to be injected inside. And then the mutator here refers to the language. So you use JavaScript or TypeScript, and package manager, reporter, and the test runner here. If you are using KARMA, it will be KARMA. If you use JEST, it will be JEST, and the test framework. So what you really enter here in this questionnaire, you will find it done here in the Stryker config.js. And then we start to run and see what's going on in our code. So let's now see the case that we had for our code. So here we say we have 100% coverage, right? So let's see what mutation testing will tell us here. So as we see here, this is a configuration that we have for Stryker. The JavaScript path, the mutators, the reporters, and here, because this is a custom JavaScript project, the project type here is set to custom. If this is an Angular, it will be Angular CLI. If it is React, it will be React, okay? So let's run Stryker now. Stryker run. So now Stryker is trying to inject mutators into your code to see what's going on. And it generates a file here. So let's see the generated file. Wow, you see? This is the actual efficiency that we had for our unit tests. So if we go here inside the rent price classifier class, we will find the actual efficiency is 79%. It is not really 100%. Why? You will understand why now. So here you can click any of these red boxes to see the problem which happened. So in the beginning here, it tries to just remove this string literal and put it to an empty value. And it runs unit tests, and unit tests succeed, no problems. Why? Because traditional code coverage didn't really check the asserted logic. This is a logic. This is a logic, a line logic, right? Audit manager.log, it should really be asserted, right? So the traditional code coverage couldn't really detect this, because the traditional code coverage is fine as long as we run unit tests and it executes the line. It doesn't really matter if you really validate this line or not. So here, mutation testing, it tries to just remove the value of the string literal. It tries to make it empty and run our unit tests, and unfortunately our unit tests succeeded. It didn't have this. The other problem here is it tries to change price less than 1,500 to less than or equal 1,500. This is another problem that we had. So when we did our unit tests, we didn't really check the boundary conditions. We checked some values. We checked some value from the low price, some value from the high price, some value from the very high price, some value from the medium price. But we really didn't validate the edge conditions, the boundary conditions. So mutation testing here is trying to challenge these boundary conditions. It tries to make, okay, I tried to make it less than or equal 1,500, and it really worked. You know, your unit tests could not catch this problem. And it tries to do the same with the next condition and the same with the last condition. So how can we solve this problem? In order to solve this problem, we need to assert every line of code that we have. Sometimes there are some lines of code which are not really so important to validate. It is really up to you as a developer. But every line of code should be unit tested if it is really some valuable line of code. Sometimes you may have some line which is, like doing some console log or something like this. So in this case, okay, it is you don't really need to validate something like this. But if something like audit manager.log, this is a logic which needs to be validated. And also here we need to validate the boundary conditions that we have. So let's start to incrementally fix this problem. So in the beginning here, let's assert console audit manager.log. So we will assert this line. So what we will do here to assert this line, we will spy on audit manager log, and we will call the classify method. And finally, we will assert that the log method is called with this exact parameter. So when mutation testing will try to change it, our unit tests would be strong enough to really fail to assert this logic. So let's see. As we see here, the audit manager.log line is fine. It tries to change it, but it failed to really change. The mutation, the logic change fails to really fail our unit tests because we really asserted this line of code. So let's try to assert other lines of code. Let's try to validate the boundary conditions. So here we validate the boundary condition. So if we have 1,500, it will be average. If we have 2,000, it will be expensive. And if it is 3,000, it will be very expensive. Let's save and rerun. As we see now, we are now really covered. This is a very important thing that I think we need to do to make sure that our unit tests are really efficient. So we should not really be deceived by traditional code coverage reports, because I saw this in many projects. You know, like if you have 100% code coverage, then yeah, our code is bug-free, our code is strong, our unit tests are really strong, like we are really we don't have regressions. It is so impossible that we have regression. Actually, you can have regressions because mutation testing is really trying to challenge your code and try to change the logic and try to really challenge the unit tests that you really develop. So mutation testing is one of the tools which allows us to understand and to see if there is some logic that we had which is not asserted before. So what if you are working with other frameworks? Some people, like have their own homegrown frameworks, and other people, like using frameworks like Angular, React, Vue. So fortunately, Stryker is compatible with Angular, compatible with React, compatible with Vue. For Angular, you just need to make sure that you are having Angular CLI 6.10 or above. If you have Angular version that is before this, then I don't really recommend to have this because the configuration steps would be so big. So upgrade your project to Angular 6.10, and you can really use it. So let me show you an example now of Angular. So again, this project is available in GitHub. Feel free to download it and start playing with it and ask me if you have questions. So let me show you this project. How many of us is familiar with Angular code? Okay, so I will explain it high level. Again, this is a generic concept. Now It works with custom JavaScript, and it can work with other frameworks. So if you are not familiar with Angular, not a big deal. Not a big deal at all, you know. As long as you know JavaScript, you can use this tool. So let me show you in Angular what did we do here in Angular. So we have, let's run this project first. It is just one component. It's called a repository list component. It goes to GitHub and retrieves GitHub projects which are related to Google, which are owned by Google. And what it tries to do is just rendering this list of projects. So in the initialization of the component, we call some service called the repository service to get the project list. And once we have the project list, in the onSuccess part, we just set the project list to the actual binded project list here with a table which shows us the list of projects. Yeah, because we don't have internet connection here. Yeah, if we have internet connection, it should show no data available in the current time because there is no internet connection. If there is internet connection, it will show you the data, which is really a good case, a good test case for this project. So what we did here in the unit tests is in this unit tests, we asserted every line of code like what we agreed here. We asserted subscription, add subscription, subscription.add. We asserted subscription.unsubscribe. And we asserted successful project list and when there is an error, when there is a connection error, for example, we asserted it here. And as we see here, because we don't have internet connections, we really didn't have any projects, which is a good test case for this. So after we run Stryker, we will see this report. Here in Angular, if you are familiar with Angular, there are some certain lines which are really part of the template of the component. So here it tries to remove the styles URL, for example. For me, this is fine. This is really fine not to assert this line because in Angular, you know, like this is just a CSS. You cannot really assert CSS unless, you know, you have other better idea. But as long as you have all of the logic of your component covered, then you are really good. So it tries to challenge the Angular component code, tries to remove blocks, tries to change expressions, and it really works fine. I know that we are running out of time, but this is important resources which you can check. This is the project URL. It is a GitHub project. It's called the Stryker Mutator. And these are the demos of the project. I'm here available in the conference. If you have any questions about this technique, let's discuss this together. And thanks so much.
Thank you, Hazem. As Hazem said, we don't have time for questions.